so we're going to go over this question which uses a parallelogram law. Okay, so we call this the parallelogram method of adding vectors. Okay, so when you take any vector, right, a vector is generally represented like that, that being the head, and obviously this being the tail. Now there's a rule here. If we got two vectors, right, it's always head to tail or tail to head. We cannot add vectors when both of these are coming out. As we can see, so we have got two tails here, and that's not going to work. So the classic mistake done by students here is they will say, oh, that's 3 Newton, that's 5 Newton, that's my resultant. Not good. That's not how you do it. So we're going to do it using the method called the parallelogram law, but actually in the form of what we call a scale diagram. So everything's going to be drawn to scale. The first thing to do in this sort of question is to choose the correct scale. So if I have got a force of 3 Newton and 5 Newton, and I want to fit that on my exam paper, I think it'd be wise to use 1 centimeter represents 1 Newton. Why did I do that? Because I know that this is going to be 3 centimeters and this one's going to be around 5 centimeters. So to be drawn to scale, 1 mark for that. Okay? I'm going to change color. What did we say? 1 Newton, 1 centimeter represents 1 Newton. So quite clear now. I'm going to start off here, and I have got my 30 centimeters here. So I'm just going to do that line. So that's my 3 Newton force. Make it a bit thicker like that. Right? Use my protractor then and measure my 5. But actually, it's actually better if you do it here. That's my horizontal line. That's my 60 degrees. That's my point. So what do I need now? I need to measure 5 Newton going along this way. So if I do mark it, that's 5 here. And there you go. Stops here. So that's my 5 Newton, my 3 Newton. And this is my start. And I finish off here. How do we do the resultant? It's start to finish. You draw it like that. And if I was to measure it, you draw it with 2 arrows, and that's my resultant. Now, let's measure this value. So that would be 7 centimeters. So the resultant is 7 centimeters, but each centimeter is equal to 1 Newton. So that becomes 7 Newton. And notice that you could have gone the other way. What you could also have done, you could have put this 5 Newton here at an angle of 60. Let's see if this works. At an angle of 60. And if you were to measure 5 Newton starting from here, going through this, 5 Newton, that's my 5 Newton force. And if we measure this correctly, this should be 3 Newtons, and that gives you again that same resultant. Whether you go for the red route or the blue route should give you the same answer. But that's not finished yet. We're now expected to, because it's a vector, it has to have direction. So the way we're going to go work out this direction, the easiest thing to do is to take bearings. So you start from the north, right? 10 degrees, 20, 30, 40, 50, 54 degrees. You could say it's a bearing of 54 degrees. It's the easiest thing to do. It's a bearing of, let's check that again. So that's 10, 20, 30, 40, 54. 54 degrees. Like in some other books, there are other ways of writing it. I generally prefer bearings. Okay, but you could say, you can measure this angle, and you'll find that this angle is 10, 10, 20, 30, 36. You could also say making 36 degrees with 3 Newton force. A lot of marks in the exam for this. So let's quickly review it. Vectors have to flow in one direction. The resultant is measured from the start to the finish. You start by choosing your scale, you draw them, you label them, and you make sure they flow in one direction. Then you measure this length. This length is then converted back using a scale to give you 7 newtons. And then after that, you've got to measure the angle. Whether you measure this angle in this case here, which was this, or you just simply do bearings, whichever one is easier.